Okay, welcome to today's class, which will be based on probability. Probability is one of my most favorite topics in mathematics. In all of mathematics, I really like it because it has a lot of logic to it, and there are very few formulas that you have to remember. Most of it is based on logic. So I will introduce you to some simple problems in probability that you might have seen, and we will try to solve them in different ways and try to understand what is the thinking that goes behind probability, why probability is important, and how it actually functions. Okay. So the first thing is the entire science of probability, everything from start to finish, is based on chance. Okay, it's based on luck factor, it is based on chance. uh, and in most cases nothing is certain. We just try to predict what might happen. So if you watch any sports, in the beginning of the game, they say there's a chance that this team can win. They say this person can score these many runs, or they say that from this situation, India has won so many number of times. They have lost so many number of times. If this player plays well, India will win. If this player doesn't play well, India will lose. So all of that is based on probability. It's based on chance. Nobody can say with any certainty that something will happen, right? There are even matches where Bangladesh has defeated Australia and nobody would have predicted it before the match, but it can still happen. So probability does not guarantee you what should happen, but it gives you a very good picture of what can happen or what might happen. Okay, so that's how probability works. Some of the things that you have to remember when talking about probability, some important things are that the first the first important thing is that the sum. So if you so let's think like this, that let's say there is some chance that something will happen. Okay, and then we'll say there's some chance that something cannot happen. If you add those two together, you have to reach 1 or 100 or whatever that is. So probability can sometimes be fractions or it can be percentage. If it is percentage, then you're doing it out of 100. If it is fractions, you're doing it out of 1. So like for example, I can say half a chance, or I can say a 50% of a chance. So there's is the same thing, but if I say that there is a 20% chance that something can happen, then there is a 80% chance that that thing cannot happen, because the total probability is 100. Okay, some simple things. Let's say, what is the probability that the sun will rise tomorrow? That is 100. Okay, we define that probability as 100. It's a certain event. If you want to be technical, you can say that, oh, there is this minute chance that the entire universe might collapse tomorrow and the sun might explode and it might not rise. But that is so small that it's invisible. It's not even, you cannot even consider it. It's 0 point, maybe a 50 zeros and a 1 or something like that. Okay, so we don't think about that. We just say that there's a 100% chance that the sun will rise tomorrow. So then there is a 0% chance that the sun will not rise tomorrow. So the two of them have to add up to 100. Okay, that's extremely important. And in most cases, in most probability problems, it's always simpler to figure out one of the two. Either you figure out if an event can happen, or you figure out if an event can not happen. It's sometimes difficult to do both of them. So what we do is we see which one is easier to do, and then we subtract that from 100 or from 1, and then we get the other probability as to whether the event cannot happen, or if you did it for cannot happen, you get it for the event can happen. Okay, when you toss a coin, there's a almost a 50% chance that it is a heads, and there's almost a 50% chance that it's a tails, and there is a very small chance that the coin can stand on the edge. Okay, now in this case, the chance that the coin can stand on the edge is lot more than, let's say, the sun not rising tomorrow. So we cannot say that if you toss the coin, it is 100% that it will either be heads or tails. There is a possibility that it can stand on the edge, especially if it's a 5 rupee coin. Then there's a higher chance of that. But for the sake of probability and for the sake of convenience, let's just assume that that is also tiny. Let's say that our coin will not fall like that. We'll say that it's 50-50. Also, you have to remember that there are very few coins in the world that are actually fair coins. In the sense, most of the coins are slightly biased to one side. That slight bias is very, very, very slight. It's not that it's extremely, biased, but almost every coin is slightly biased. There's a slightly greater chance of a head, or there's a slightly greater chance of a tail. Then there are some coins that are actually biased. Like those coins are prepared for games and for things like that, where they are actually biased. There's a uh, 2/3 of a chance that it's a head, and there's 1/3 of a chance that it's a tail. So it's like that. So those coins are biased to either be a head or a tail. So it could be for some game purposes, or Ketan, sorry, Vishwam, but can you turn off your audio? Okay. So those coins are specifically designed to play such games, where you want one thing to have a slightly greater chance. Okay, and sometimes people can cheat. Like for example, if you know the Mahabharata, the Shakunis dice, those were rigged. So biased, it's the biased. Do you know what's the meaning of bias? We say that the teacher has a bias to that student, which means she's partial to that student, or such things like that. So bias means favorable. So a biased coin is more favorable to being a head than a tail, or being a tail than a head. So Shakuni's dice, it was biased to behave the way he wanted. I mean, that's not probability. There's some logic that he controlled it or something like that. But I'm just giving you an example. Okay. So when we talk about probability, there are three main problems that are usually solved. Um, One is coin, one is dice, and one is cards. These three are the most basic concepts in probability, and throughout your high school, and you will see problems that are related to this. So let us try to solve some problems for these three concepts. Okay. Just wait for a second. I don't know why this is not coming up. Okay, here it is. Is it visible? Okay, thank you. And Vishwam, you didn't miss anything much. I was just giving an introduction to probability. You can see that video later on YouTube when I upload it. Okay. So let's first talk about coins. This is extremely interesting. Let's start with the coin. So I'll give you a simple problem to start with. Now, I'm not explained explicitly what probability is and what we're actually trying to do, but I just want to propose a problem and see how you guys solve it and what is your reaction to that problem. Then let's try to understand what we actually should do. Okay, I don't want you to type the answer. I don't want anybody to type the answer. Please obey. Just think about this problem and just think about it for a couple of minutes. After a couple of minutes, if you did not understand how to solve it, or if you did not get the answer, just type in the group. But if you get the answer, just be silent. Don't type done, don't type finished, don't type got it, don't type anything. Okay, wait for a couple of minutes. So what is the chance that if a coin is tossed 2 times, both will be heads? Heads. Which means there's a coin, I toss it, I want it to be a head. And then I toss it again and I want it to be a head again. So what is the chance that both of those times it will be a head? So if you did not understand how to solve this, please type in the group. Okay, very good. So the answer to this problem is 1/4. Okay, or we can say 25%. Because the thing is, this is dealing with a, so now that we solve this problem, let's try to understand what probability actually does. Okay, probability is the way by which we figure out what is the chance that whatever we want happens. What is the chance that a favorable outcome happens? A favorable outcome is something that we want, okay? And we divide that, the total number of favorable outcomes, we divide that by the total number of outcomes, favorable, unfavorable, everything, and we get a percentage. So if there are 5 outcomes possible, and out of that, if 3 outcomes are what we want, we said that the probability of that favorable outcome is 3 by 5. If there are 100 events possible, and out of that, let us say 75 are favorable outcomes to us, then we can say the probability of that happening is 75 by 100. In this case, when the coin is tossed twice, there are 4 different things that can happen. One is both of them might be tails. One is we might have the first coin a tail and the second coin a head. Then is we can have the first time it is a head, then it's a tail. And the fourth time we can have both of them as a head. Okay, these are the 4 possibilities. There's nothing else that is possible. When you toss 2 coins, you only have these 4 possibilities. There's nothing else that is possible. Okay, so we cannot have a possibility where both of them are not a head or a tail. That's not possible. It has to be either a head or a tail. So we are ignoring the slight chance of it falling on the edge, so we are not thinking about that. So out of these 4 outcomes, there is one outcome which is favorable to us. That is this guy, 2 heads. So the probability theorem, or it's not a theorem, it's just a logic, it says there's 1 out of 4. So the probability that both of them are head is 1 out of 4. And this can, if you just multiply it by 100, you'll get 25%. So it's very simple to convert it from a fraction to 100 to a percentage. You just multiply by 100. If you want to convert it from a percentage to a fraction, you just divide by 100. So there's no rocket science. This is extremely intuitive and understandable, this first problem. So now that you know this logic, I'll give you another one. Let's say, what is the chance that if I toss the coin 10 times, all 10 are tails? What is the chance that if I toss the coin 10 times, all 10 are tails? Now you have to think a little bit how to do this problem. You cannot actually list down all the possibilities. There's too many possibilities. You can't start from head, and all the way up to tail to tail. In this case, there are only 4 possibilities, so we could easily do it. Here, there are 10 different things that are possible. So I think the dice is unfair. What does that mean? Coin. Oh, no. What I'm trying to say, the coin is a fair coin. Okay, the coin is a fair coin. And what we are trying to solve is, see, okay, even if it's we are not talking about any unfair coins. Okay, it's a fair coin, and even if it's a fair coin, there is a chance that it can become a tail 10 continuous times. It is not impossible, but that it's a very low chance that it can happen. It's very difficult for that to happen, and we have to figure out what is the chance that it can happen. Okay, I don't want anybody to type any answers. That rule applies throughout this class. Actually, not this class, throughout my life. Okay, till whenever I teach you, that rule applies as to you should not type an answer if I don't ask you to type it. Do not tell anything. Okay, just don't type anything there. That will just ruin people's flow of thought. Once, this is the second time you're typing the same thing. I already told you once not to do it. I don't know why you're doing that again. Okay, good. So just try to solve it on your own. But let me explain the problem. So this is not an unfair coin. Okay, it's a fair coin. We are not saying that 10 times it will be a tail. We are saying what is the chance that 10 times it can be a tail. We just want to get hold of that quantity. So I want to know, for example, I want to know, let's say, what is the chance that tomorrow in the cricket match, India will score 500 runs, or let's say for 400 runs, let's say 400 runs. It's not it's not easy for that to happen. It's very low chance, but I can still say that there is maybe a 2% chance that it can happen, or I can say there's a 3% chance that it can happen. So it means a slight possibility. So we are not saying that this event has already happened. We are trying to calculate what is the likelihood that this event can occur. Okay, now how do we solve this? We don't have time to list down all the possibilities. We don't have time to look at any pattern, but we do have to realize this: how many favorable outcomes are there? That is still one. Okay, because the favorable outcome is talking about this one event that we want. In the first problem, the favorable outcome was that the two times the coin has to be a head. In this case, the favorable outcome is the event where 10 times it's a tail. It doesn't mean that there are 10 favorable outcomes. The favorable outcome is only one. Remember, this entire event is one thing. Tossing the coin 10 times is one event. And we want to figure out how many different ways that event is possible, and out of that, how many different ways are there where we can get what we want. What do we want? We want all the 10 coins to be tails. There is one way by which that can happen. Okay, there is no two ways by which it can happen. There's only one way, and that one way is that the first, the second, the third, the fourth, all the coins have to be a tail. Okay, 1 divided by, now the denominator should have what? It should have the total number of events that are possible. Sorry, the total number of. Okay, sorry. I think, yeah, someone closed my audio. Please don't do that. That's not funny. Can you tell me what was the last thing that you heard?
Sir, the 10 possibilities.
Okay, good. So in this, not two events. I said there are, in the first problem there were four different ways by which this thing could happen. In the second problem, we have to figure out how many different ways are there by which this event can happen. Okay, are you guys very clear with the fact that there is only one favorable outcome, and the favorable outcome is that all the coins have to be tail? That's one outcome. Okay, now we have to figure out what are the total number of outcomes. How do we solve that? Okay, let's think of it this way. There are 10 coins. Okay, each coin can be a tail or a head. Each coin can be either a tail or a head. Okay, now first coin could be a tail or a head, the second coin could be a tail or a head, the third coin could be a tail. So each coin has two different ways of existing. Now suppose you had two pants, two shirts, and two different pairs of shoes. How many dresses would you have? How many different ways of dressing up could you have? You could have with the first pant, you could have the shirt, this shirt and that shoe. With the second pant, you could have this. You could have two different pants. For each of them, you could have two different shirts, and for each of them, you could have two different shoes. So you have two times two times two. You could have eight different outfits possible. Do not add two and two. It's not six. It is eight, because for each of those clothes, you can fit them with each of the other clothes, right? So the first thing can happen in two ways, the second thing can happen in two ways, and the third thing can happen in two ways. So it is 2 multiplied by 2 multiplied by 2. So in this case, there are 10 different coins, and each of those coins can exist in two different ways. So if we look at all the possible ways in which it can happen, it will be 2 multiplied by 2 multiplied by 2 10 times. That will be 2 to the power 10. 2 to the power 10 is 1024. Now, if you have any question, just tell me. Do you have any question? And this is 0.0009766. Extremely low chance of this happening. It's less than 1 out of 1000. It's 1 out of 1024. So the probability of this event is extremely small. You cannot toss the coin 10 continuous times and get 10 tails. I mean, cannot, in the sense it's very unlikely that it can happen. Now ask me a question. If you didn't understand why this is 1024, ask me a question. Did you understand why it is 1024? See, always remember the number of coins that you are tossing, the number of ways that are possible will always be 2 to the power that number. So if you have 2 coins, it will be 2 to the power 2, because you have 4 possibilities here. Each coin can be head or a tail. So head or tail multiplied by head or a tail, 2 multiplied by 2. If you have 3 coins, it will be head or tail multiplied by head or tail multiplied by head or tail. So 2 times 2 times 2. See, I can actually list, I'll show you why it is 2 to the power. So I will show you for 3 coins. Okay, so we can have head head, head tail, tail head, tail tail. Okay, so this is 2 coins. Wait, so let's do for 3 coins. Okay, so there are, yeah, I'm explaining. It's not 27, it's 2 to the power 3, which is 8. So see here what has happened. Actually, let me move all this to the next page so that you can kind of see a pattern. Now there are 3 coins. Okay, this is coin 1, coin 2, coin 3. The first coin can be a head or a tail. The second coin can be a head or a tail. The third coin can also be a head or a tail. So for each of the coins, because there are 2 ways of existing, the total ways will be 2 times 2 times 2. So you will have 4 methods where the first coin is a head, then you'll have 4 methods where the first coin is a tail. Can you tell me why it will be 4 for each? Because let us say that the first coin is a head. Okay, let's say we are only looking at the possibilities where the first coin is a head. We are not bothered about the first coin being a tail. Let's only look at first coin being a head. Now there are 2 other coins. There are the second coin and the third coin. 2 coins can exist in how many ways? Did we had listed it here? 4 ways. It can be head and head, head and tail and head, tail tail. So there are 4 ways possible for these 2 coins when this is a head. That the same combinations that we listed for the 2 coins. Now you can have the same thing where the first coin is a tail. Again, you can have the second coin head head, head tail, tail head tail. So 4 plus 4. It will be double of that. Now if you increase the coin by another one, why it will be another double is because now you can make the first coin as a head, and now you will have 3 other coins remaining. Correct? You'll have 3 other coins remaining, and we know that for 3 coins there are 8 different ways. So with the first coin being a head, you can have 3 different coins that can be, organized in 8 different ways. So you'll have 8 ways where the first coin is a head. Now you can make the first coin as a tail and again get all these possibilities. So it'll be 8 plus 8, it'll be 16. Now if you put a 5th coin, it will be a double of that. So it just keeps getting double every time. Now are you able to understand the logic? 2 to the power 4 is 16. Then it becomes 2 to the power 5, which is 32. So in this case, there were 10 coins. So it is 2 to the power 10, which is 1024. That is why, right? So if we said that India is playing a World Cup with 10 matches, and we say that what is the probability that they win the toss in every match? It is 1 by 1024, because in every match there is a half chance that the toss is correct, right? It could either be correct or wrong. Now when we say the toss is correct, we don't mind whether it's a head or a tail. That is okay. It depends on what the, so they should win the toss, so that is also a 50-50 chance. So let's say that the opposition captain says head, this Indian captain says tail, then there is a 50% chance that we win the toss. So you have to win the toss in the first match, there's a half chance, then again you have to win it, there's another half chance, half chance, half chance, half chance. So there's every game there is two possibilities. So to win every toss, it's very unlikely. Okay. So winning the toss is a very good example of trying to make it a very even match. You don't want anybody to have an advantage. 10 to the 24 is 2 to the power 10. 2 to the power 10 is 1024. You should always remember the powers of 2. That's highly useful. So I always like to list the powers of 2. So it goes like this. See, this is 2 to the 7, 2 to the 8, 2 to the 9, then 10, 11, and 65,536. These are the first 16 powers of 2. Yeah, not memorize them, but you can just multiply everything by 2 and calculate it, right? So 65,536 is 2 to the power 16. And I think that was the number of rows that were there on the Microsoft Excel when I was in school. I think now they have made it to 2 to the power 2 to the power 20. I think they multiplied it to something more. So that is more than this. Anyway, so when you talk about coins, it's always important to remember that the total possibilities is 2 to the power n, where n is the number of coins that are being used. Let's go to the third problem. Now I'll make it interesting. If 3 coins are tossed, what is the chance that at least 2 coins are heads? Please stop playing with the 2 to the powers. We will do that some other day. Now tell me, if 3 coins are tossed, what is the chance that at least 2 coins are heads? Now, uh, I know that you can actually list out the possibilities, but try to do it without listing it. Let's see if you can do the problem um, without listing all the possibilities. When I say listing, tail, 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 head, 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 don't do that. Try to think and see if you can do it without doing that. Aryan, what did I say about 12 minutes back? So what is the chance? I'm not asking you the total number of outcomes. Chance is, I want probability. Whenever you say probability, it should be the number of favorable outcomes divided by, thank you so much, divided by the total outcomes. So suppose, Aryan, whatever answer you gave, that is not the probability, that is the number of events. Now that has to be divided by the total number of events, and that will give you probability. Okay, so probability is always represented as a fraction or a percentage. Don't just tell me, like, for example, here you don't say that the probability is 1. It's not 1, it is 1 by 4. Okay, so think about this. At least 2 coins means that it should be 2 or more. We don't mind even if all the three are heads, but we want at least 2 coins to be heads. And we don't want the possibilities where only one coin is a head. So that will not count. We want at least 2 coins should be heads. Okay. So let me. Does anybody want to explain how to do this problem? Did anybody get the answer? So not. I don't want the answer, but does anybody want to explain how to do this problem? If you're interested, just type yes, and then I'll. Okay, Parv, you can turn on your microphone and try to think. Yeah. Hello. Not audible. Okay.
Sir, wait 1 minute.
Okay.
Sir, am I audible?
Yes, very audible. Not audible.
Sir, you said that. Sir, I am
Yeah.
audible.
Yes, audible.
Sir, you said that if 3 coins are also head, then it's okay. So, sir, we have 2 cases. One of 2 coins and second of 3 coins. So, sir,
Okay.
all
Okay.
possible cases is 2 to the power 3, which is 8. So, 2 upon 8, which is 1 by 4, and 1 by 4 into 100, which is 25%.
Hey. Second, so it is not the number of cases, it is the number of possibilities. So are you saying that we can have 2 heads in only one way and 3 heads also in only one way?
Yes, sir.
Okay, fine. Okay, thank you. So now let us first list all the possibilities so that you get I've actually listed it here. You can just, oh, why did I delete it? Anyway, well, this doesn't take long time. There's a way to list it so that you don't we want it in any sequence. Yeah. Anyway, now first case of 2 coins being heads, 2 heads. Let me write it as 2 heads. And the second case is 3 heads. We need all these cases because we want at least 2. If I had said exactly 2, then we only care about just 2 coins being heads. But in this case, we are at least. So now let's first look at the first case and let me color all of them blue. This is one case where there are 2 heads. Okay. This is also one case where there are 2 heads. And this is also one case where there are 2 heads. Now there's a second case of 3 heads. This is the only case where there are 3 heads. Let me color this also blue because so now there are total possibilities are 8 and the number of possibilities that we want are 4. Correct? Because there are 1, 2, 3, 4. 4 by 8 is 1 by 2 is 50%. Interesting. So there is a half a chance that at least 2 coins will be heads. Which means if you toss 3 coins, there is a 50% chance that at least 2 coins will be a head. And there's also a 50% chance that at least two coins will be tails. How does that work? Why does it work like that? And is there a way to solve this problem without listing all these possibilities? I'll tell you how to do it without listing all the possibilities. You just have to think intuitively. Because we don't usually have the time to list down all the possibilities. So how do we do this? The second case is simple. We know that there's only one possibility for this one. This is straightforward. We know that all the 3 coins being head is only one possibility. In this case, there are 3 possibilities. 1, 2, 3. How do we think of that intuitively? So we say that we want 2 coins to be heads, which means only one coin should be a tail. Does that make sense? If two coins have to be a head, then one coin has to be a tail. Now we say, in how many ways can that one coin be a tail? There are three ways, right? It could be the first coin in this case, which is a tail, or it could be the second coin in this case, which is a tail, or it could be a third coin in this case. So there are three possibilities. So we know that there are three possibilities for this case and one possibility for this case. We add the two of them together, so we get a total of four cases. This is the probability. If you have any questions, please ask me. Not at all. You don't have to write the cases every time. It is almost impossible to write down, because sometimes the problem will have, like for example, in this case, how will you write down the problem? I gave you these cases for you to understand what we are doing, but then I told you how to do it without writing the possibilities. So we tried to think, right? So now we will actually do this without the cases, without writing all the possibilities. You just say that how many ways can I have two heads? That means that it could either be first and second, second and third, and first and third. So there are three possibilities. How many ways can I have three heads? Only one possibility. So total is four. And 4 by 8 is 1 by 2, which is 50%. Any other doubt? Waiting for all your queries. In the meantime, let me give you one last problem. This is probably the most confusing problem, but I really like it. So this is the last problem that I'll be doing with the coins. Vishwam, can you show, okay, what you're saying, number of favorable outcomes divided by number of total outcomes. Yes, so in this case, we have four favorable outcomes. Parv, you are testing me. Really, I told you not to type anything. If you get the answer, it's okay. You don't have to show off. Please. All of us will know that if you didn't type anything, it means you got the answer. Just type something if you have a doubt. It will distract other people. Please. Okay, in this case, there are four possible favorable outcomes and there are 8 total outcomes. Okay, so that is what it means. This 4 by 8 is number of favorable outcomes divided by number of total outcomes. Favorable outcomes I've colored in blue because favorable outcomes should have at least 2 coins as heads. Okay, very good. Okay, Parv, please wait for 2 minutes. Vishwam, all of you just think for some time, try to solve this problem. If I toss 2 coins in the air at the same time, okay, now listen carefully to this problem. If I toss 2 coins in the air at the same time and find out that one of the coins was a head. So now both of the coins have fallen on the ground, okay? I'm not looking at both the coins. I just look at one coin and I find out that it's a head. Now, what is the possibility that that other coin, which I have not checked, is also a head? What is the possibility that that other coin, which is not yet checked, it has fallen on the ground, we have not looked at it, we only looked at one coin. What is the possibility that that coin is also a head? This is a very controversial question, meaning I have been part of sessions where we have discussed about this problem for a long time, but I will not make it confusing for you guys, and I will actually tell you what the correct answer is so that we don't get into that discussion now, because that can maybe confuse you a little bit. But try to think of the same logic which we have used for the previous problems. Look at the favorable outcomes, look at the total outcomes, and try to tell me what is the possibility that that other coin is ahead. Not try to tell me, try to tell yourself, okay? And then when I tell you to tell it to me, then you tell it to me. Sometimes depends on the way of toss. No, 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 we are not going into those things. See, this is probability, it's logic. We are not talking about how the coin was tossed. If you sorry, I hope somebody is not doing that intentionally. If you are not interested in the class, just go. Please do not play all these games and make it hard for other people, okay? Again,
Sir, now you are again not audible.
okay. Is it audible now?
Now you are.
Okay. Thank you. Okay. So, how do we do this problem? The first thing we will do is we will list down the possibilities because this is a small problem and there are only two coins that are being tossed. We can afford to list down the possibilities. Okay, so we will list down. Okay, now two coins have been tossed. We have found out that one coin is ahead. We don't know about the other coin, but we know that one coin is ahead. So, which is the possibility out of these four that cannot happen? Out of these four, which possibility can we rule out? Very good. It is tail and tail. This cannot happen because we have seen that one coin is ahead. Okay, we have seen that one coin is ahead. Now we want to, so now what happens now? We have done something very important which we had not done in any of our previous problems. In this case, the total number of outcomes now is not 4, it is 3, because we have eliminated one outcome completely. It's not about whether it is favorable or anything, it just doesn't matter to us anymore because that event cannot happen. So we are not going to include it in our probability formula because that event cannot happen. This set of events is only the events that are possible. They are all the possible outcomes. Okay, so now we have found out that the tail event cannot happen, so that's gone. So now there are only 3 possible outcomes. Now out of this, which are our favorable outcomes? This is not our favorable outcome because we want the other coin is also ahead. In this case, the other coin is not ahead. In this case also the other coin is not ahead. So this is the only possibility where the other coin is ahead. With one coin is ahead, we already know that one coin is ahead. So this is possible, this is possible, this is possible, because in this one coin is ahead. See, we are not bothered whether it's the first coin or the second coin. We don't know that because now they are in the air and they've just fallen. We know that one coin is ahead. So it could have been this case, it could have been this case, or it could have been this case. And now we want the other coin also to be ahead. So that is possible only here. Therefore, the number of favorable outcomes is 1. Number of total outcomes is 3. So probability is 1 by 3. Vishwam, it's not 4 because that telltale event cannot happen. The telltale event could have happened before we checked. So when we tossed the coin, the telltale event could have happened. But after we tossed the coin, after we had a look at one coin and we found out that that one coin was ahead, then our total outcomes suddenly becomes 3. The possibility of the telltale outcome has been eliminated. So now our probability is calculated on only 3 possibilities. Yes, that is important. That is why this problem is slightly different from the previous ones. Because in this case, one event cannot happen. So one outcome cannot happen. So the probability is 1 by 3, which is 33.3%. Okay. So there's a 1/3 chance. It's slightly non-intuitive. So when you think of coin tosses, you always think of half or quarter or 1/8. But in this case, the chance is 1/3. It's lesser than half. It is more than 1 by 4. Okay. So is there any doubt with respect to this problem? 33.33333, 33.3 bar, but anyway, is there any doubt with respect to this problem? If there's something that I didn't understand here. So suppose I asked you, what is the can you now quickly tell me the answer to this without doing any formula? If you remember what I told you in the beginning of this class, can you quickly tell me what is the probability that the other coin is a tail? I don't want you to use any formula. I don't want to do any listing. Just by memory of what I told you in the beginning of the class, can you tell me what is the possibility? Wrong. Lavnish, wrong. Tanmay, wrong. Very good, Parv. Vansh, wrong. Aryan, wrong. Only Parv is correct. Remember, guys, all the sum, Tanvi, very good, 66.6. The sum of all the possibilities can only be 1. If this coin, so the probability that this coin is ahead is 1 by 3, which means the possibility that it's a tail has to be 2 by 3. The total has to be 1. And even you can even look at this. Our favorable outcomes is still 3. The tail cannot happen because remember, one coin is still ahead. So we have 3 possibilities. Now, what is the possibility that the other coin is a tail? It cannot be this one. It can be this one. It can be this one. So the number of favorable outcomes would be 2. And the total outcomes would be 3. So it's 2 by 3. So it might confuse you a little bit. How is it that there is a more chance that it can be a tail? That is because one coin is already ahead. We know that one coin is ahead. So there's a lesser chance that the other coin is also ahead. There's a slightly more chance that the other coin is a tail. Because it's a little difficult for both the coins to be ahead. That's a little difficult to understand, but that's how probability works. You might say that how is it like that, but you can look at the events, you can look at the possibilities, and we know that the one coin is a head and the other coin can be a tail two different ways, because the other coin could either be the first coin or the second coin. We don't know that. Is there any question? Please ask me if there's any doubt. If something is looking a little confusing, let me know. Vishwam, Aryan, Tanvi, anybody, any confusion? Logical? Yes, this is very logical. So the thing with probability is sometimes your common sense might contradict it, but you have to think in such a way that you understand that, okay, actually this is what is happening. For me, this problem is one of my most confusing problems. When I was first looked at it, I was so confused as to how can it be that the tail is 2/3 and the head is 1/3? But now that I'm explaining it to you and I'm telling you why it is like that, it's very clear to me, and I don't want any of you to have that confusion. Okay, so I will stop the recording and then we will look at the problems that you want to ask me. Just a second. Let me stop the recording.